Okay, so today I am going to teach you how to understand battery like I do. And I'm trying to make this as easy as I can and how I understand it, okay? And I'm trying to interpret it the easiest way I can understand. And people like me will be able to understand a battery, how they actually work. Now, I'm going to hold the camera in my hand, so you're going to see a little shaky. It doesn't matter what size they are in. They hold pretty much, it worked the same way, as everybody knows. But, as you know, bigger battery lasts longer, and smaller battery, like the AAA here, is less. And I'm going to show you a diagram how they actually work. And also depend on the metal as well. Okay? Because of one thing that you need to remember. Densities. Okay? Now, imagine this battery versus this battery. Right away, you know which one will last longer and which one are more capable holding a charge longer and better, and in this world they call it amp. Now I'm going to take here and I'm going to start to do a drawing, and I'm going to try to make it as simple as I can for you. It is very easy to understand, and it took me a while to figure this one out as well. You can call me a dummy if you like. But this is how I understand it. Now, as you know, this is a lead battery. Lead acid battery. This is pretty much the same thing. These are actually solid, okay, because it's the different material that they squeeze in. But as you know, and you know in this world, lead acid battery works the best, even though a lot of people don't like lead. But they work the best because they have the acid in there, and the sulfuric acid. And I'll tell you what it actually does. Okay. Now, for the lead acid, I'm going to explain that, and then you can configure this one out by yourself, or I'm just going to do two. What happened is, inside here, there's lead plate, okay? I'll make it as simple as I can. This here, let's say this is positive, and this side is negative. Now they have plates come from here. I'm going to draw them like this because you're going to find out in a minute why. I'll just make 3, okay? So that way it will be simple for you. They actually go all the way to here, but I'm trying to make it as best as I can. We have to extend this a little longer so I can make the next plate. But they do, as you can see, they do not touch each other. I need to make this longer so you can see. As you can see, they do not touch each other. And I'll explain to you why. And it's a simple, very easy to understand why. And remember, this whole thing is contained in acid. Okay? So all these here are liquid acid all around. Okay? I'm actually going to make it as an X. It'll be easier. So the X will be acid. Okay? They're all over the place. And they prevent these from touching each other. Because if you have put liquid in here, like water, They automatically touch each other, because liquid is a conductor, but not acid. Acid is not a conductor, and that's why they use acid in here. Now, in these form here, some of these here, they put a separator, which is a plastic piece. When it's a solid, they put a separator. So instead of acid, they put a separator between these, and then they roll them in. Okay? That's how that goes. The solid one invented a little bit more different. The graphite pretty much is the same way. You would put one layer and one layer and one layer, and then you merge them in as you connect them. So that way one side is negative and one side is negative and one side is positive. That's all there is. Now, when you put a charge in, electricity, as we all know, electricity, particles, or you would call not particles, but electrons. I don't know. They are particles to me. But electrons, in this world, they call it electrons. But remember, it is a particle, okay? What happened is, each one of them, we're going to do a circle. Okay? Let's say I'm putting a charge here. That's my negative. And this is my positive side. And I'm giving you, pretend these are tennis balls. Okay? Same thing here. They're all tennis balls. And these are your room. So, when I feed the negative in, it's gonna fill up. So now we got a bunch of little balls sitting in here. Bunch of them. They'll try to go in as much as they can. One pushes the other. One pushes this one in. This one pushes this one in. This one pushes one in, because electricity likes to attract to metals. So they fill it all up. When this is filled, it can no longer squeeze together. It's full. And that's why the battery is full. Same thing over this side. They'll try to fill it. As they push each other, it creates heat. Because as you know, if you and I clap our hand together for a while, our hand will get hot. Well, for faster way, you can rub it together. Well, imagine these things are rubbing each other because they're pushing each other into these metal. Remember, they are attracted to electrons, the metals. And that's why people get electrocuted if you take a piece of metal and you stick it in here. Especially on the hot side, you will get electrocuted. Because the metal would attract, let's say if I stick it in here, the tennis ball will start to move into this piece of metal right here, then it transfers to me instantly, because the electricity was designed to attract to metals. And that's why it works so well in this lifetime. It's just filling up. Now my battery become full. But then you ask, why don't it actually move from here to here? Well, it can't, because you're blocking it with acid. So acid is all over here. Prevent them from jumping positive to negative. Now you can actually dump the acid out, But if you dump the acid out, the electron will leave. It can't stay. So basically, the acid, it's actually containing the electrons. Hold, more like it, would be a term for it. So all these here, just to hold the battery, just to hold the electron in here. And that's why it stays. Without the acid, the electron will move, still move to the lead. It'll fill up instantly until it's compact. Because here's the difference, okay? Let's say this is, if you look at the chemistry of metals, you would see lead and you would see gold. Of course, the chemistry is actually different. I'm just doing this so you would know. This is for lead and this is for gold. Lead have less density than gold. Gold is a very high density metal. Lead, it's just this. Okay? So the electron are able to find room to attach itself in here. And that's why they use lead. They use other metals as well. I won't get into that because then it'll get confused. We just want to stick with lead today, so it'll be easier. Lead and gold will be the quickest and easiest way to explain this one. Okay? Now, because of the density of the metal, of lead, the electron are able to come into here and stay. Now, if you use this in gold, it would have less density, which means it actually would be less electrons to flow through. Although gold is a better conductor because it's so solid that it moves faster. It pushes each other faster because if you have more room in here, let's say this is lead and this is gold, and each one of these is a tennis ball. Unfortunately, gold is too dense. Okay? So when you push the electron in, it has nowhere to go. Let's say if I have only 2 balls here, and I try to squeeze into here, it's going to be harder. But if I try to squeeze into here, it'll be easier because I got plenty of room. Understand that? So, if you make this bigger, then you get more tennis balls on each side. More tennis ball, more electrons. More electrons, more amps. Amp. If you want to study that in amperage or whatever, you can look that up by yourself. But as far as we know, it's just counting the electrons, more like it. Okay? That's all you needed to know. And that's why they have ratings on here if you look at it. 115 amps hour at 1 amp. So if you take 1 amp out of here, let's say if you draw, which means you're taking the tennis ball away, you would get 115 hours at 1 amp. If you put that 10, then it will be 11.5 hours only. You get it? So basically, all this is doing is that if you draw more, if you be able to get, if you be able to suck out more, then you multiply or divide it accordingly, according to your draw. Which means if you have a device able to suck these tennis balls out one by one, and let's say this is 115 hours, just one, it would take you 115 hours to take all of these out. But if you take 10, if you're able to take 10 out at a time, then you know you only last 11.5 hours. Because you're taking 10 amps. Meaning you're taking 10 tennis ball out per hour. Get it? The rating on that. Now, it is very easy to understand. All there is just you're putting the tennis ball into here until it filled up all these spaces. Then it can't take anymore. And that's when the battery go overcharge. You're forcing these tennis balls to go into here and compact them together. Same thing with the positive. The positive will attract to one side. The negative will attract to one side. And that's how the battery works. It is the easiest and simplest way I can explain to you how they actually work. It's as easy as that. That's how easy to understand these. And just imagine an electron is a tennis ball. You're filling this room up, which means this big container right here, that's your room. In your room, you will have these rods or plate or whatever it is. Doesn't matter. You arrange them in a way that they do not touch each other. And when that happens, you need the acid, which is all the X's here, to prevent them from touching each other, or sort of like you're containing them. That's what that acid does. You're containing it. But you cannot put water in because you would conduct it. So you need something that you can contain them. You can hold them. And that's, you can hear terms all the time. The battery's not holding its charge. The battery holding its charge. Well, if you have less acid in here, the battery is going to start losing holding its charge because you're not containing them. That's the quickest way and easiest way I can explain to you. And that's how that works. And that's how a lead acid battery works. All there is just tennis ball coming to here to fill up all these rooms, as you see, all these little circles, and then it can't fill no more. When you force it in some more, it becomes neutral and it becomes hot. And electricity will try, okay, remember that, will try to squeeze into these things. As it squeezes into these things, it creates a friction. That friction, it makes this thing hot, warm, because these will excite. They're not excite, they're just pushing each other so they can squeeze into here. As they push into each other, it creates frictions. That friction there create heat, and that's how the battery gets hot during charging. Warm, not hot. But if you overcharge this, then guess what will happen? This will start it to get hot because it has nowhere to go. You're filling it all up already. There's nowhere to go. That's when it's starting to leak. This will expand if it has to expand. And when it's contained, if it expands, it will burst. And that's what causes explosions. And that's why they clearly said do not overcharge these things, because it will explode. Certain things like this right here, they'll give you a warning on it. It is actually not an explosion. It's just that you have too many tennis balls. When you have too many tennis balls, where does it go? It has nowhere to go, except for bursting out. So if this was a room and you're trying to fill all the tennis balls in, one tennis ball is negative and one tennis ball is positive, and you just throw them in, or even black and red, you throw them all in, you squeeze them into this room. Let's say you have a room right here. When the room is filled with tennis ball and you try to squeeze more in, the room will blow out. Not blow out, but it will expand. And then when it can't do it no more, the room will burst. And it's the same principle as a battery. And that's how a battery works. It is very simple to understand if you use this method here as tennis balls. So the tennis ball, the electron, each one of these is a tennis ball. You're trying to squeeze them all in here. But the tennis ball preventing from touching each other by using acid. And that's why they put acid. That's why lead acid battery works so good, is because the lead acid battery lasts so long because they preventing these from touching each other. And that's why you'll be able to recharge it. Now, when you're drawing, you're just taking these out. So you're actually making these empty again. Same principle. When you're taking it out, you're making these empty. When you're charging it, you're pushing it all in. So when you're drawing out, like when you're drawing meaning using, okay? When you're using the batteries, you're taking the electron outward. It's going to go out instead of going in. So then you have less of these tennis balls. As less and less, you will have less and less energy or electrons. When that happens, it will only hold a certain amount. And that's why you see here, even though certain of these batteries, it's actually the same size. And that's why you see different size of batteries, because of the plate that they put in. You see these plates right here. Because of the plate they put in, you need bigger. This is actually a lead acid battery. But look at it. It's only 5 amps. And it's only at 6 volt. Because it can't be this 12 volt. Although they made different cells right here. You would see different cells. Okay, compartments, and they squeeze them together, sort of like if you're trying to put these two together. That's the quickest way I can teach you or show you how to understand them. If you put them together, you create a parallel or a series in series. In series would be just the same. In parallel would be something like that. And when that happens, you're creating more. You're actually putting more electrons. So basically, if you add on to this, you add more of these plates, you need a bigger room. Because if you have bigger room, it's going to force more tennis ball in to make a bigger battery. So you got more electrons. So because electron is so small, it's able to fit into all of these plates. And then it attracts to the plate. Remember, it always attracts. It's not attracting to the plate. It's just that certain metals have different properties. Remember that one. The property, the density of the properties. But at the same time, the denser the properties push the electron faster than non-density. And that's why they use gold. They actually put gold on some of them on top of here, or they put the gold connector because they knew that gold with the density, it moves quicker. It's the opposite of this. That's how funny it is. Electron will move into a density faster than non-density stuff or metals. But at the same time, it actually contains more than other metals. That's how that works. So basically, I'm going to end this video because my 26 minutes up. Basically, the easiest way to understand a battery is to use tennis balls. Tennis ball to fill up into the room. and filling into the room until you can't fill it no more. But the tennis ball will touch each other. And you can't touch each other, because if you touch each other, you short them out. What they do is they fuse together, and that's what you call a shorting out. But to prevent that, they put acid in there. Sulfuric acid. So it prevents these from shorting out. That's all there is. And that's how easy it is to understanding a battery. It is the easiest way I can explain it. And it took me, believe it or not, it actually took me a long time to understand this concept, to understand how electron moves, how they actually made the battery, and all there is, the simplest way, all there is just the electron finding way to stay. So basically you're storing. So a battery is storing. That's all there is. A big battery like that. You're just storing the energy in there until you take it out, which they call drawing. Same thing. Taking it out, draw out, it's same thing. So that's how to understand the battery. And I hope this video is helpful to you to understand it like I do. And I hope the way I explain it, it solves some of your mysteries. But like I stated before, it is actually very easy to understand. I just didn't know how to explain it. And the way I explain this way, I hope it will help you to understand a battery. And easier to understand the battery.